Okay, so in this video, we have to differentiate using the first principle, and in this case, we have the function sin2x, okay? So first of all, let's begin by letting this function equal to y, that y is equal to sin2x. And if you're not sure that what is the first principle method, you can check this video in order to confirm and master your skills related to the first principle method. So in the first principle method, the very first step is to add an increment in the independent and the dependent variable. So delta x and y plus delta y. So I will move this y towards the opposite side of the equation. The value of y actually is sin2x, right? This was the given in the question. So I can put y, which is equal to sin2x. In the previous video, in which the function was given cos 2x, we used the half angle identity, right? We also have the half angle identity for sin 2x. So what is that identity? If we are having sin p is what? You can consider this thing as p and this thing as q, okay? So if we are having sin p and it is subtracted by sin q, you can actually write 2 cos. This identity would actually be equal to 2 cos p plus q divided by 2 multiplied by sin p minus q divided by 2. And this is identity which is related to the trigonometric portion of mathematics. So don't worry, we will cover these things in another course related to the trigonometry. But for now, we know that sin p minus sin q is equal to 2 cos p plus q divided by 2 and sin p minus q divided by 2. So over here, p is 2x plus delta x and q is 2x. I would like to multiply this 2 inside this equation. So 2x. So now it's actually pretty clear that this is my p and this is my q. So I can write p plus q. What is p? 2x plus 2 delta x. And what is q? It is 2x. So plus 2x divided by 2 multiplied by sin p minus q. What is p? It is actually 2x minus q. Minus what is q? It is 2x. So divided by 2. So these are cancelled and this would actually become 4x. So this would be 4x plus 2 delta x divided by 2 multiplied by sin 2 delta x divided by 2. I can take out 2 common over here. So 2 2's are x plus delta x divided by 2 multiplied by sin. These would be cancelled. I will get delta x. And these will also be cancelled. So I will finally have 2 cos 2x plus delta x multiplied by sin delta x. And now, in the second last step of the first principle method, we actually divide delta x on both sides of the equation. So I will divide delta x over here. I can actually put this delta x beneath any of the terms written over here because these are actually being multiplied. So I can either put delta x beneath 2 cos 2x plus delta x, or I can put delta x beneath sin delta x divided by x. And I would prefer to put this delta x beneath sin delta x. Why? I will tell you in a minute. Let's just apply the limit, which is the last step of solving using the first principle method. Delta y divided by delta x, limit delta x approaches to 0 is equal to limit. If we are applying limit on the left hand side, I also have to apply it on the right hand side. Divided by delta x. Now, wherever I am having delta x in this equation, I can put a 0 over there. So this would actually, I have a delta x over here. So I can write 2 cos 2x plus 0. But for this term, I'm not going to put a 0 over here. Why? Because I know there's another identity which says that limit of delta x approaches to 0. And if this limit is being applied to the function sin delta x divided by x, this is actually equal to 1. And I will upload the proof of this entire thing in a separate video. But for now, we know the result, that is limit of delta x approaches to 0. And if that limit is specifically applied to sin delta x divided by delta x, it is actually equal to 1. So I can write 1 over here. And if you're confused, so don't worry, I will add another step over here so that it becomes much more clear that how are we doing things over here. Sin delta x, so we have 2 cos 2x. Now this is of course equal to 1. So the final derivative is 2 cos 2x. Okay.